Alright, 8th graders, we're going to figure out exponential decay together today. So the exponential patterns we've studied so far have all involved quantities that increase. But in this investigation, we're going to explore quantities that decrease or decay exponentially as time passes. So exponential patterns in which a quantity decreases at each stage show exponential decay. The factor the quantity is multiplied by at each stage is called the decay factor. So just like we had a growth factor, that is still going to be the same, but it's going to be the decay factor. A decay factor is always less than 1, but greater than 0. So between 0 and 1. After an animal receives a preventative flea medicine, the medicine breaks down in the animal's bloodstream. So with each hour, there is less medicine in the blood. The table and graph show the amount of medicine in a dog's bloodstream each hour for 6 hours after receiving a 400 milligram dose. So if we're looking at the pattern of change in the graph and table, how does the amount of active medicine in the dog's blood change from 1 hour to the next? So at between 0 and 1 hour, it goes from about, like 400 to 100, right? And then the next one looks like it's about 25. Oh, look, this would have been easier than me estimating. And then you can see it's kind of being divided by 4, right? And we know that's the same as multiplying by 1/4. And that could be our decay factor because it's between 0 and 1. So let's write an equation to model the relationship between the number of hours, H, since the dose is given, and the milligrams of active medicine, M. So if we have M, that's what's coming out of, that's the active medicine. So we started at 400, right? And our decay factor was 1/4, or we could call it 0.25, right? That's a quarter. And we would call it raised to the hours. Very interesting. I feel like that decreases a lot. Do they give that preventive flea medicine every day? Interesting. A different flea medicine breaks down medicine at a different rate. The equation for the new medicine is M equals 60. So remember, that is our initial. So what is the y-intercept? That's 60, right? Because when H is 0, it's being multiplied by 1. What is the decay factor? Our decay factor is the 0.8. So if we complete the table to show the amount of active medicine in an animal's blood at the end of each hour for 6 hours, we're going to take our calculator, right? So this one, each time it's being multiplied by 0.8. So we have 60, that's where we're starting at, times 0.8. So we're at 48. And that times 0.8, 38.4 times 0.8. Do you see how we would do this? And you can do this too. Times 0.8, 24.576 times 0.8, 19.6608 times 0.8, 15.72864. Then we could make a graph for the data. So where does it start? Well, it starts at 0 and 60. After 1, it's at 48. After 2, it's at 38.4. At 3, it's at 30.72. Where is 30 here? At 4, it's at 24.576, so like pretty much right on there. At 5, it's at 19 2/3. At 6, just almost 16, right? So that is how the graph is going. Dun, 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 dun. That is it, guys. That is decay. So remember, things to remember. Your decay factor has to be between 0 and 1. It is a fraction or decimal. Okay? It's less than 1. So it's kind of what we would divide by, or we think about it as multiplying by a fraction or multiplying by a decimal. That's how we end up with the decay, because we only have a part that's moving on. So 8/10 of that moves on. 8/10 of that moves on. That's how it decays. And our graphs, of course, go downwards instead of upwards like our exponential growth. All right. Have a fantastic Thursday.